Day.
I had a big issue yesterday with divided by 0.
It's not posted?
Where it wasn't posted.
Huh. I'll
I'll
post them up. They're all there. I just need to publish them. All right. So yeah, let's do PA1 questions first. So where and how do we deal with divide by 0, or where do we deal with divide by 0? Remember, if your denom equals 0, right, we don't need to burst into flames or do anything crazy. We just need to record the fact that the denominator is 0. But when we try to use this fraction, when we try to add or subtract, we need to understand that this is undefined, and we need the result to be undefined. So when every time you have a new fraction, it's because you call the constructor. Okay, if you've written your add or multiply methods, you've probably figured out you have to call a constructor at the end of those to create a new fraction, right? So you can really do all your massaging of your numbers inside the constructor if you like. And really, the only thing that I did for when I wrote this was if the denominator is 0, I just forced the numerator to 1. I don't know why you even have to do that. Really, if the denominator is 0, that's your flag that this number is undefined. But I also forced the numerator to 1. That's optional. But that's all you have to do. So now if you go into your add method, if the number, right, this dot denom is equal to 0, or if the argument dot denom is equal to 0, you know your result's going to be undefined. So you just return a new fraction, parentheses 1 comma 0. Right? And the result is going to be a totally valid fraction, but it's going to have a denominator of 0, which something else down the road will treat as undefined. When you're in the two-string method, normally you're going to take the numerator and concatenate a slash and concatenate the denominator. But before you do that, check the denominator. If it's 0, just return the following string. And the last place you have to worry about this is in 2-double. In 2-double, you got to take the numerator, cast it to a double, divide by the denominator, return that. Before you do that, check the denominator. And if the denominator of your fraction is 0, just return this. Right, that's a valid double. Right, that has the type of a double, but it's equal to nan.
So in your add fraction method, if you get a 1 over 0 or some other undefined number, you want it to print out nan in the main program call?
No, don't print anything in your add routine. Don't print anything anywhere in your classes.
Hold on, but if the main program called it and then had it print something, you'd want to force the main to print nan.
Yes.
Okay.
Be really careful about this though. Right? The only thing that we're doing is, the closest we come to printing is we return a string version of our fraction. Right? And if we have to do that and our denominator is 0, we want to return NaN, 3-character string.
Only if they call the two-string method.
Only if they call the two-string method.
Okay.
Right? So if you do something like, 2 divided by 2 minus 4 divided by 4, and you take 3 halves and you divide it by this, right? Well, what's going to happen? You're going to use this thing sub 4, 4, and you're going to end up with 0 over 1, right? Or 0 over 8, and you'll simplify that to 0 over 1. And then when you do this division, you're going to say 3 halves divided by 0 over 1. That's 3 times 1 over 2 times 0. We're going to get something with a numerator of 3, denominator of 0. Okay? We can return that as the result of this divide call, and that's perfectly fine. And if your caller said, x equals all that, well, x is a fraction with a numerator of 3, denominator of 0. That's perfectly fine. We don't have to do anything more. But if the user says, print x equals plus x, this, internally, it's going to call x.toString. And in your toString code, you're going to check, see the denominator is 0, you're going to return NaN. And so this is going to say print out x equals plus what toString returned. and it does the right thing.
So they don't have to reference it as x.toString when they try to.
No, if you concatenate x, it will automatically call the toString method. And if you haven't written a toString method, there's a default one it'll call, which gives you that class name followed by an @ sign and an X number.
Okay, so that's what that thing is.
That's what that is. Yeah, it's the default toString.
I don't want to give too much away, but in our toString function, well, nah, I might be giving too much away. Do we have to use integer.toString for one type of returning?
I use that to force an integer to print with toString.
Basically, if you got 4/1.
Oh, you can do that, or you can just do x plus and double quotes with nothing in between. That's enough to trick
I
it.
did that the first
I was
time.
gonna do that, and
Yeah.
I'm like, that seems ridiculous.
It is a little silly, but it's pretty common.
So when you return a string, it has to be a variable and something in quotes.
If I return x, it's going to say you can't return an integer.
Yeah,
I'm
that's what
expecting a string.
Mm-hmm.
So we're really just tricking it into forcing x to be a string so that it can concatenate it. And yeah, it's like, you know, while 1 = 1. It's just something that happens sometimes. But yeah, the other way is to call a toString method.
One is definitely duct tape.
Yeah.
So you're saying doing a lot of like your heavy lifting in the constructors is not a bad idea?
No, in fact, things are cleanest if you do pretty much all your work in the constructors. Because once you're outside the constructor, you've got a fraction, you know that it's been normalized, right? It's in simplest terms. If there's a minus sign, it's on top, and whatever else you want to do to put it in a known state. So yeah, if you want to call your reduce function in your constructor, that works pretty nicely.
Yeah, I was doing it at the end of every math one, and then
Yeah.
I realized you could do it in your constructor because you're constructing it, and then you would do that. But then
Right.
that's pointless.
Yeah, just throw it in your constructor.
So
Perfect.
that was a question I was going to ask you earlier was it a good idea to call your simplification inside a mutator or just to do it in the constructor and pass it into a mutator?
So the main program never calls the simplify, right? So you don't really need it in like a mutator or an accessor, right?
Because mutator returns to the main function.
Yeah,
whereas
typically.
The other functions are not returning; they're just staying here.
Yeah. Okay.
And your reduce function doesn't need to take any arguments, and it doesn't really need to return anything because it's inside your class, and it just basically adjusts the numerator and denominator and leaves them in their simplified form. So you don't have to actually pass it anything.
I'll talk to you about that.
Yeah?
I mean, I got it. I just don't.
Okay.
I can't give it away.
Yeah. And one thing that I've seen, so I've seen this happen. Let me see if I can reproduce this.
If you call the fraction that you send into your function, you can call it that, fraction that, and then you can put this.
So one thing I've seen people do is in their constructor or in their math routines, right, they figure out the numerator and denominator, and then they call this reduce function, and they have this return a fraction, and then they pass that fraction back, right? That's really way more than you need to be doing, right? Reduce is perfectly fine, just like this. Right, it doesn't really ingest anything, it doesn't really return anything, it just operates on two fields inside the fraction class, the numerator and the denominator. And so you can call
Does
reduce.
that has to be private, or does that not necessarily matter?
It really doesn't matter, but I want you to make it private. We were talking about this before class started. The main reason is that if it's not private, something outside of your class can access it. And some user somewhere will discover you have a reduce method and they'll start using it. but maybe they don't know what it does. Maybe your reduce only works on positive numbers, and they'll call reduce with some negative numbers and expect it to find the right thing, and it doesn't. And so we limit the visibility so that we only expose the things that we really intend the outside classes to access. So that's why I asked you to make it private. Then you can sell it, man. $10 billion.
Is the main you had on the spec sheet pretty close to what you're going to be doing?
Yeah, that's definitely the biggest test I'll run, but I might try some others. I don't know. But I think that hits all the edge cases.
So to get at our like intent in D, when we do that, like the void reduce, we would have to do this dot reduce or something.
You could definitely use this dot numerator, this dot denominator.
This dot.
But if you don't have a local variable named numerator or denominator, if you just say numerator, it'll get the one from the class. So it's got the usual scoping rules of programs. And when we do something like this, right, so this is a method named area. If we had, you know, an integer w, and inside here we say w, this is what it's accessing, right? But if we don't have this and we just access w, this is in some sense global to this whole class because it's defined outside of a function. So it's kind of the same scoping we're used to with C. If you think of this as all one big long file, right? Stuff that's declared outside of a function is essentially global. And so normally if we just say w or numerator or denominator or whatever, it's going to hit this variable it's declared as part of the class. The reason we use this in mutators is because usually we have an argument and it's got the same name as this global variable. So we use this dot h to make sure we're picking up this dot h.
That's what's cool about Java, right? Is that you have data and you also have functions inside of your class.
Yep, that's the whole point. That's really the big difference between a structure in C and an object, is throwing the code in along with the data.
I think that's what I was getting hung up on. I emailed you last night because I had questions about all this. Kind of figured out this morning.
Did I write back?
I don't know. Because I sent you.
You sent me a snippet of your code?
Yeah, I said
Yes.
that I would ask a question in class.
Yeah.
I mean, it's kind of all.
Yeah, and that's what this was about, right?
Yeah.
This idea that, so my comment in my response to you was think about reduce, does it really need to return a fraction?
Yeah.
And if you think about it like this, you can get away without actually returning anything.
Yeah, because I was thinking with C blinders on.
Mm-hmm.
So
Yeah.
That's
Very,
I
very
started
common.
with
I was
the
having
exact same
issues
thing.
with like for the entire thing I was writing. The biggest thing that was hanging me up was what do things take in and what do things return.
Right.
And I was I need to get away from how C does it.
Yeah, that's a big conceptual leap from non-object to object. Cool.
So, I have a question about dividing division. If
Mm-hmm.
you have something that's not numbered, you have like 1 over 0, and you divide by that, that would end up being something that's no longer not numbered. Should we handle that or just let it happen?
Anytime you operate with an undefined number, the result's undefined. So yeah, if you just well, I think division's going to end up being 0 over 0. But maybe there's something you can do with 1 over 0 that if you just do the way that we do addition or subtraction, might end up giving you something defined, right? Don't do that though, right? As soon as you see this as one of your arguments, just return an undefined fraction. Right, and definitely don't print any messages. Okay, that's a big no-no. Okay, we're not really considering this to be an error. So if your result of an operation is undefined, just return a new fraction 1 over 0. Or something to map to undefined. Yeah.
So on the Linux, the engineering server, if
Mhm.
you tab completion in the shell, so like I have the .java and the .class file, it'll automatically up to the dot, and then it starts to print it once I can put it.
Mm-hmm.
On my own Linux machine, if I do Java C and I do tab completion, it will always do .java. And if I do the Java, it'll always just do the name of the file. And
That's
not
cool.
the suffix. Yeah, I was just wondering if you knew like where that's happening.
I'm not sure how you set that up, but I've observed that different things happen with completion, and I think it's one of these things where there's just a lot of different knobs you can set to say how do I want you to complete. But if you figure that out, post it on the discussions, because that's probably useful for a lot of people. And it's probably somewhere in a bash RC that's being set up. But that's tricky because you've got a .bash RC in your home directory, but there's a system-wide .bash RC, which is executed for everybody, and that usually invokes one or more other .bash RC files, sometimes with different names. And it's designed to be very general and very customizable, but it becomes this big spaghetti ball of things running other things. So it can be kind of hard to figure out exactly where that's being set up. But yeah, I'd be interested in seeing that. And I'm curious. Oh, it does the same thing on my system. I didn't even realize that. But not on the Linux server. That's interesting. All right, well, maybe I'll dig into it one of these days too. All right, other questions? I don't know if anybody's memorized my office hours at this point, but I'm changing them up. So engrcs.com/schedule is always up to date, and my schedule on my door is up to date now also. So I'm putting more hours in the middle of the day and spreading out my lab hours for 250. All right, let me finish talking about scanners a little bit here. I said I was going to talk about files and doing scanners from a file, and we haven't gotten to this yet, and this is going to take us to a few other topics. And then I want to talk about PA2, and then I want to talk about Eclipse, and then it's going to be 150 and we'll be out of here. So, but let me say a few things about scanners, and this open. Upset the some deities there.
Nice day. It's been so long.
I know. The next few days are supposed to be nice. Perfect weather for writing Java. All right, so this was our scanner class, right? So this was reading lines, tokens from standard in, and we could run this as we could just feed it its source code, and it breaks our input up into tokens, okay, things separated by space. So what I want to talk about is how we do this from a file instead of from standard in. And it's pretty easy. Here we're constructing a scanner saying system.in, that's called an input stream. But instead we can say the following: new file, and the name of a file. So file is itself an entire class. And one way we can construct a file is by giving it a path name. And so if we do that, we're saying I want to open this file called data.txt. We're constructing a file object, and then we're passing that to the constructor of scanner. So we're doing two things here, creating a new file and using that to create a new scanner. And scanner, one of its constructors, is passing it a file. All right, so this should read from data.txt instead of standard in. But if we try to compile that, first error we get is that it doesn't know what the word file is. Okay, and we ran into this with scanner also. So file comes from java.io.file. So we've got to put that in our imports. So that'll tell it where a file is, but we're still going to get a compile error. And in this case, our error is unreported exception. File not found exception must be caught or declared to be thrown. And it's complaining about line 9, which is where we use the scanner constructor. And it's actually a problem with the file constructor. So what is an exception? An exception is like a software version of an interrupt. It's something that can happen and suddenly your program goes somewhere else and does something different. Okay, in a hardware interrupt, you push a button, and now instead of doing this next line of code, you jump over to location 8 or 18. Sorry for the flashbacks. And you start executing code there. Okay, with an exception, same thing. You're going to try to open this file. If this file doesn't exist, that's an unexpected situation. And instead of going on to the next line of code, you're going to jump somewhere else. But we got to tell it where to go if this exception occurs. Okay. Now in C, you get an exception. What happens? Segmentation fault. End of story. Okay. Here, it's going to ask us to actually put something together to handle this exception. And if you look at the documentation on these things, for example, the constructor for a file, it'll show you that it can throw an exception. That's the terminology for creating an exception, throwing it. So it can throw various exceptions in different cases. So we have some keywords in Java to help us do this. So the first keyword is try. And we can put a series of statements in here. And it will try to execute each of these statements. And if it succeeds, great. But if one of these statements throws an exception, it will give up on these statements in this try block, and it will look for the keyword catch. And it will start executing the statements in this catch block. And when it finishes, it moves on from there. It does not go back and retry these other statements. So the idea is execute, execute, execute. If all that works, great. Ignore all of this. Okay. So if no error, it's going to do all of these things. But if an error happens in here, it jumps down to the catch block, does all of this, and then it continues. So we can put code in this catch block to respond to an exceptional condition, like the inability to open a file. And catch, it kind of looks like a function definition. We actually have to specify an argument. And the easiest type of argument is an exception. And usually these exceptions are just called E. That's just the name we use, but it's just a variable name. And what is exception? It's another class. Of course. And so we're saying that E is an object of type exception. And it comes with a bunch of methods available. Not too many methods. but one of them is print stack trace, which is kind of useful. And this will show you the list of who called who, called who, called who, down to the point where the exception occurred. We can also say get message. We can convert it to a string, and there's all kinds of other things we can do. And we're not going to have to worry too much about these details. Most of the time, we're just going to say try, blah, catch exception E, blah. Okay, so let's put this in code and see what happens. So I'm going to put this statement in a try block. And I'm going to say catch. And there's my argument. And I'll print an error message. Something went wrong. And I'll print out E, the argument that it passed to the catch block. And then I'm going to do a return so that I exit there. So that'll compile. And now if I run this, it says something went wrong. And it gives me the two-string version of this object E, which is the name of the exception and then some additional information, data.txt, no such file or directory. So we have to add this try-catch business because Java forces us to handle errors. But really the only thing we've changed was in this constructor for scanner, instead of constructing with system.in, we constructed with new file. Yeah? That's exactly what it's doing. Because we're concatenating E to a string, so the system's calling E.toString. And if I actually said E.toString paren paren, it would do exactly the same thing. It's just doing it for us. All right, so if I create a data.txt, and I run my Java program, now it successfully opens the file, and the scanner is pulling in tokens from that, and there's the output that we expected. And if data.txt is inaccessible, it exists, but the permission is set to 0. When I run it now, it says something went wrong, and my error message says permission denied. And I could interrogate that E object, right, and find out if there was a problem because the file didn't exist or permission was denied and so on. And I might do something different in each case.
So if your program ran with like system privileges, would it be able to access those files, or is it still off by 0?
Good question. Oh, it's going to be tricky. Yeah, I could probably do that. Yeah, so that works fine. So sudo says run as root, and root has access to all files even if the permission is 0. So that's a way to do file input, and that also gets us into thinking about exceptions. And we can have multiple catch blocks. And we can have different types of arguments in here. Just like methods have different signatures, we can have multiple catch blocks, but we could have one particular type of exception here. So exception is a class, and it's sort of a class that covers all different types of exceptions. But there's other versions of exceptions as well, like ACL not found exception, activation exception, already bound exception. Somewhere down here is our IOException. IOException. So we could have a catch block that just says IOException E, and only if we generate an IOException will that block of code be executed. So we can start splitting up how we want this thing to respond in general. But an IOException is also an exception. So if we have a catch block that says catch an exception, every exception is going to get handled by that block. So those are nuances. We don't have to really worry about those. This is enough to get us working. Let me throw one more tweak in here. Suppose I do this. I put my scanner s equals new scanner inside here. And I try to compile, it's going to complain. And it's complaining down at line 16 saying there is no symbol s. In line 16 down here where I'll say s.has next, well, I defined s to be a scanner right here, but I did it inside this block of code. It's local. So there's a lot of scoping to variables in Java. If I declare it up here in the beginning of my main method, it's global to this entire block of code. But if I define it inside a for loop or a while loop or a try block or a catch block or most other blocks of code, it becomes local to that. And outside of this curly bracket, s doesn't exist. So sometimes you got to be a little careful with where you define these things. Yeah.
So even though it ran that code, it's still like threw it away after the try block?
Say again?
Like even though it ran the code in the try block, it like got rid of the variables after.
It didn't compile.
Oh.
Right. So when I try to do this, I actually got a compile error. Mm-hmm.
Isn't it the reason why we use this, that, something? What you just said?
So we could use this if we had a variable defined up here, right? Then we could access that with this.
Yeah.
And these are always awkward to talk about in English because we talk about this being that with this.
So everything in the try block is guaranteed to run the first time. Anything that goes wrong, that's where all those catches are for.
So it will execute as far as it can. If something goes wrong, it'll jump down to a catch block.
Is it wrong to call it error handling, or are we just?
No, it is error handling. It's
Okay.
exactly what it is. Error and exception are the same thing.
Okay.
Yeah. And we can also throw a finally block on at the end that'll get executed regardless. And there's lots of things we can do with this. We'll talk more about exceptions later on. Well, that's enough to get you using things that throw exceptions.
Sounds like an impatient teacher with that setup of language. Try this. Catch all
Try
this.
this, yeah.
Finally, do
Does
this.
the catch need to be on the same line as that ending bracket, or is that?
No, no, the positioning, the formatting is all totally random. I think I do it the same, but
Wait, is Java like C where it doesn't care about spaces?
doesn't care about spaces.
Okay.
Yeah.
So if you wanted it to look like an FL statement, like try catch, like how we've been doing this evening, you drop the catch down.
I'm sorry. Catch
Say again?
You just put catch on another line.
Yeah, you put catch on another line. Right, I mean, this will work pretty much.
Yeah, it does. Catch on the same line as the ending bracket.
Yay. There's always contests to make like different versions of code, either the most unreadable or the most pretty or the least pretty or things like that.
Garbage,
Yeah.
garbage white space
Pretty.
characters. It's in a text file. It's all in one line. There's no word wrap.
You
Yeah,
have functions that are just one long line.
yeah. Or we used to have programs that would turn code into like, a Snoopy calendar or something. It's like moving it around.
It's so fun.
All right, cool.
Just unreadable.
Is there a way to make it read, like the word system, for instance, but separate all the characters out onto new lines, but have some way for it to know that they're connected?
That I don't think you can do very easily.
Because I was wondering if you could like backslash or whatever.
Yeah, within a keyword, it's going to be pretty picky about spacing. but you could probably fake something that would look kind of like that. I mean, you could put a comment with a bunch of backspaces in it,
Yeah.
maybe like suppress.
I mean, it's probably a good thing if that doesn't exist, because
That would be cool, something that like turns your program so that it displays with all the words backwards or something, by just putting comments and backspace.
yeah, scrambling.
That would be neat.
Having a code for your code.
There's a good SLP.
Isn't it good? I don't know.
Yeah, how to drive your lab partner crazy.
You want to stop giving ideas?
All right. And any problems with the ODP that I posted this morning? Looks like a lot of people have already done it.
Oh, it's due tomorrow, right?
Due tomorrow, yeah. It's array access. All right, let's talk about PA2. Okay, so I made up PA2 last night, and it's posted. All right, so let me give you a disclaimer up front. PA2 is probably the hardest program in this course. Okay, in the sense that it's very data structure oriented, and you're building these data structures by hand, and it's probably the first time you're working with serious data structures in Java. So with all of that together, it's probably going to be the most challenging of the 5 programming assignments, okay, or any of the labs. The remaining programming assignments will do a lot more. Okay, we're going to make GUIs, we're going to do networking, they're going to be very powerful programs, but we're going to rely more and more on things that are already available for us in Java. So those in some sense will be fewer technical details in terms of, you know, having to write all this stuff yourself. So PA2 is going to probably be challenging, okay? But if you approach it the right way, it's just a large number of very small steps. And each of these steps is a few lines of Java. Okay? Now if you step back and you look at the whole thing and you look at the pictures that we're going to draw up here today, it can look really overwhelming. But if you keep in mind that we're in an object-oriented mindset, that this supports code reuse, that we can be modular, it's a bunch of little steps. Okay? And it's a lot of fun. Because we're doing things we did in 222, but in a much more modern context, which is Java and objects versus pointers and mallocs and arrows. Okay, so that's my disclaimer up front.
Besides the fun part, it's the same disclaimer for physics. Oh, it's just
Yeah,
a small thing.
Exactly, right. All right, so you're making a word index utility. Okay, we've done this before. It's going to read input, it's going to break it up into words, and it's going to record where each word is in the input, and it's going to make an index.
War and Peace.
Yeah, and you can run it on War and Peace. And so an index, right, you can pick a word and it'll say, okay, it occurred here, 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 and here. Okay? All right, so your final word index utility is going to do 4 things. Okay? Read text from standard in and break it into tokens, which I'm going to call words from here on out. And this is the simplest version of parsing possible. Okay, so if your input is something like this, the whole tokenizing, just break things up at white space. So here's a word. That includes the comma. Here's a word, here's a word, here's a word, here's a word, here's a word. And this is exactly what you get with scanner when you say has next and next. Okay, by default it delimits things by spaces, end of lines, new lines, things like that, and it gives you the stuff in between. So you don't have to do any of the fancy parsing that we used to do where we say ignore these characters and treat these characters in a certain way and so on and so forth, okay? Whatever scanner.next gives you, that's your next word, okay? The only thing you have to do is convert it to lowercase. So if it's got letters, you want to convert those to lowercase. Scanner.next gives you a string. How do you convert a string to lowercase? Name of the string dot to lowercase, paren. Okay, really, really easy, because it's part of the string class. So you have to do almost no work for this first part.
If there's a string of all numbers, can you still send that to,
Mm-hmm.
and it'll be fine? It's not gonna
It'll
be-
do the right thing, which is nothing in that case. All right, so you're going to create a scanner on system.in, and you're going to make a loop while scanner.hasNext string temp equals scanner.next dot 2 lowercase, or you can say temp dot 2 lowercase equals, or temp equals temp dot 2 lowercase. All right, so that's the first part. That's easy. That's just scanner. Second part, you're going to remember what the position, you're going to keep track of what position you are in the file. So initialize some variable to 0. Each time that you call scanner.next, just increment that variable. So the first word you read, that's position 1. The next word is position 2, 3, 4, 5, and so on.
Program counter.
Program counter. All right, the third part is where all the hard work happens. You want to build a data structure that remembers the position of each word in the input. There's an example later on in here, we'll go through that. But you're going to remember the position of each word, and if a word appears more than once, you want to remember all the positions where that word appeared. And you want to collect all that information. So if hello appears in 5 different spots, you can, in the end, print out the word hello occurred here, 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 and here, and list all those 5 spots. Okay, so that's what the fourth part does, and you print the words alphabetically, and next to each word you show where each word occurred. Okay, that's the high-level behavior. Here's a sample. So suppose this is our input. Hello, this is a test. This is fun. Test, test, hello, goodbye. So if we think of this as word 1, word 2, word 3, 4, 5, and so on, here's the position of each word. Hello is word 1, this is 2, is 3, is 4, test is 5. This occurs again at position 6, is at position 7, fun at 8. And then test will occur at positions 9, 10, hello at 11, and 12 at goodbye. Okay, so that's what we're doing in the first 2 steps. We're just keeping a running counter, and we pull in each word. Okay, we build that into a data structure. It's going to be a list of lists. Okay, a linked list where each node has a linked list. And we'll draw some pictures shortly. But when we're done, this is what we would like to know. Hello occurred at positions 1 and 11, this at 2 and 6, test at 5, 9, and 10, and so on. And then we print out a sorted list, so sorted by the words, showing each word in our input and the locations where it occurred. That's your final output that you want to be able to produce. Clear so far? All right. You're going to implement 3 main classes to do this. And there's going to be some other classes you'll need to go along with these, but 3 main classes. The first one is called a position list, and it's just a linked list of integers. Okay, and we're going to use this to store each of these pieces of information like 5, 9, 10. So along with the word this, there's going to be a linked list. It's a position list that stores the numbers 5, 9, and 10. And then if we encounter the word test at location 17, we'll stick a 17 onto the end of that position list. Okay, so each word is associated with a position list. The position list, plain old 222 linked list of integers. All right, the second thing is a word list. And the word list records this set of words. So this is also a linked list. It's a linked list of strings. So each node has a string, which is a word, has a pointer to another node in the word list, but it also has a position list, which is this, 5, 9, 10, or 1, 11, or whatever. So we've got 2 kinds of nodes now. So we've got what we can call a word list node. And it's got a word. And it's got a pointer to another word list node, or null. But then it's also got a position list, which itself is a linked list in the old-fashioned sense. And here's a number, and here's another number, and so on. So it's really a linked list of linked lists. And we'll make a detailed picture with an example shortly.
Why use a linked list of the positions and not just an array?
Because an array, we'd need to know how big it is ahead of time, right? So the whole advantage, well, one of the advantages of a linked list is that there's no inherent limit to it. Other than that, an array would be fine because we're not inserting things in the middle. But that would be the other reason typically, is if we wanted to be able to delete or insert in the middle.
Can I see your the paper again?
Yeah. We're going to do a better picture soon.
Is there a pre-made linked list in Java that we can
There is. Enjoy not using it though.
Ouch.
So yeah, there's linked list classes. There's classes for all the stuff that we might do in here, right? But for this assignment, and it'll specify it in writing here, you got to write your own, okay? And that's really where the fun is. I mean, it would also be fun to do this with the built-in classes, but it would really be about 10 lines of code at that point. So you could do that afterwards, but.
Is it at least simpler doing it in Java than C? Because we're not going to be doing like arrows.
There's no arrows, there's no mallocs, there's no stars.
Oh, wow.
There's none of that stuff.
Do we have to use it in the
So just
Yeah, I'm sorry.
It's probably going to feel the way that you would like it to have felt in 222. Okay? My sensation with Java, at least, is that, if I want to do this particular thing, I can pretty much just go and write some Java code that says do this particular thing. Okay? In C, you can't really do that, depending on how you think, right? I want to create a new node. Well, I got to call malloc, and I got to figure out how many bytes I have to malloc. I have to check the return value, and then I have to say arrow, node dot such and such, and we kind of cut through a lot of that in Java. Okay, so we'll do some sample list code, and that'll get us going with this, and I think it'll make a lot of sense. All right, so we have a position list, we have a word list. Our third class is called index utility, and this is the main workhorse, but it's actually the easiest of the three classes because all it does is call things from the other classes. So index utility, when you construct it, it doesn't do anything. It does initialization if you need, but it comes with one method, which is a build index method. And when you run that build index method, it reads standard in, it breaks it into tokens, it builds the indexes, and when all is said and done, it returns a word list. And that word list is your index. So index utility.build index basically returns this. Okay, this linked list of linked lists.
So returns it unpopulated? Or
No, populated, fully populated, based on your input.
So our main class is just going to be for printing that out once we get it.
Yeah, basically constructing a build index utility, calling build index, and then printing it out. All right, so some methods that you're going to want. So position list, your constructor, all it has to do is whatever initialization you need. If you don't need any initialization, you don't need a constructor. But if you want to initialize some things, do it in there. And it needs to have a single method, which is add. And it takes an integer argument, and it just creates a new node with that data, and it sticks it to the end of the linked list. Right? So position list is a linked list, and add something to the end of the list. Word list has two methods. One is add word, which takes two arguments. It takes a word and takes what position you want to remember that word being at. And it updates this word list. And we'll do that in a picture next. And then print goes through the word list and prints out each word along with a list of the positions where that word was stored. So traverses the word list, and for each node prints out the piece of data, and then traverses the corresponding position list, prints out those numbers. And then index utility has this single method, build index. So how do you use this? Here's an example of a main program, and check this out. It's 3 lines. Okay, first line we say construct an index utility, and I'm going to call that myIU. Second line we say let's run the build index method in that index utility, that myIU. And the thing that it returns, I'm storing that in an object called myList. And the third thing I do is myList, let's call the print method. And those 3 lines will print the index of your input. And if you really want, you can put that all in one line, right? Like we've been doing with some other things. We could say new index utility dot build index dot print . And that'll generate our index and print it out. Okay, so marvel on that for a moment, right? This is object-oriented methodology, right? We're not traversing lists, we're not using loops, we're not doing scanners, right? All of that machinery is embedded inside these classes. And the feeling here is we create this index utility. Okay, we say go ahead and build an index, and it gives us back our index in the form of a word list. And that index, among other things, comes with a method for printing its contents. It's called a print method. And so if we have that word list, we can just say print, and it should spit it out to standard out in the format we want. Okay, this is the part where it's really fun. Yeah, yeah. So if you work with a friend, you say, I'll write the main program, and you write the classes. All right, so let's draw a few pictures, and then we'll take a break. Okay, so let's do some weird sample input, just so we don't need crazy pictures. Let's say our input is hello, fun, fun, hello, good fun. There's our cryptic input file. And let me just note the position of each of these. And I'm going to put a comment here, I'm not alphabetizing. Because to alphabetize, we need to insert things in the middle of lists and change pointers. It's going to make the picture really messy. So you need to alphabetize, but to alphabetize, all that means is when you insert a word in a list, you insert it in the correct place so that your words are alphabetized. Okay, you did this in 222. So you start at the beginning and you find the spot where your word belongs, and you sandwich it in between the 2 nodes. That should come before and after. But I'm not going to do that here. Okay, so I'm going to do the unalphabetized version of PA2.
Is that insertion sort?
It's not really a sort. I mean, yeah, it kind of is. Yeah, technically. Because we're putting it in the right spot. Yeah, actually.
Because that was the one where you're sorting it when you're putting things in.
Right, right. So we're always keeping the linked list sorted. So yeah, it's an insertion sort. Cool. All right. So we open a scanner on system.in, we say, well, it has next, and it does, so we say next, and it gives us hello, and we convert it to lowercase, so it's just HELLO, lowercase. And we're going to call, we're gonna make an empty word list, right? And we're gonna call add word, and we're gonna say add hello to position 1. Okay. And that's going to give us the following. So this is a word list. got a word, hello. And it's got a next field, which will be null, because there's only one thing in our word list. And it's got a pointer to a position list. And our position list has the number 1 where that word occurred, and that's the only thing in the list. So that's null. Okay, we call scanner.next, we get the word fun, we've incremented our position to 2. We call add word and we say add the word fun to position 2. So it checks the first word, that's not fun. The next word is null, we're at the end of the list, it creates a new node. It stores our word. It makes that the last node, it has the previous node point to it. So that's just adding to the end of a list. And then this points to a position list containing that index 2, followed by null. Okay, now we ingest the next word, and it's fun. And we check our word list. Hello is not fun. Fun is fun. Okay, so our word's already in there. We don't want to create a new node in our word list. We just want to add another reference to fun. So what do? We take this field that points to the position list, and we call its add method, and we say add the number 3. And that's going to create a new node, set the value to 3, have its next be null, and take the old end of the list and point to that new node. All right, we read the fourth word, that's hello at position 1. Same thing is going to happen. Hello is already in our word list, so we make a new node, store a 4, change this to point to that. Now we got 4 words in our word list. We ingest good, that's not a word already in our list, so we make a new node, store good. Have the previous node point to that, that doesn't point anywhere. And then this points to a position list, stores the position of good, and that's the end of the position list. And then finally we read the word fun, that's already in our word list. So we go to the position list and we say add a 6 to the end of that position list. Well, here's the first node of that list, here's the second, that's the end of it. So we make a new node, put a 6, that points to null, change the old end of the list to point to that. So if this was our input, this would be the word list that we want to get back from the build index method. And it has everything we need to know about our index. Right, here's a list of words, and for each word we can see all the locations where that word is referenced.
How are we gonna get back to, like, we had hello and we did 2 funs, how do we get back to hello? Do we have to traverse like a whole set of word lists?
So every time that you want to insert a word, you start with the first node of your word list. Okay, and I don't have sentinels here, you could have a sentinel. But I start with the first word of the word list and just follow it through, right? And we're not alphabetizing, so in practice, fun would have gotten inserted before hello, and then good would have gone between fun and hello.
So if there's one spot where there was hello and there's one spot where it's hello, comma, those are 2 different words?
Mm-hmm.
Okay.
Yeah, so what is a token? It's whatever scanner.next gives you. What comes before what? Does 1, 3, comma come before or after exclamation mark hello? It's whatever the string compare method gives you in the string class. Right, so there's a compare method you can use to alphabetize things. In strings, just use whatever it does. And don't worry about the fact that when you run this on War and Peace, you're gonna have punctuation and numbers and all kinds of other things. That's fine.
Are we going to talk about that, or is that something we need to figure out?
Talk about what?
The converting to, alphabetizing it rather, using whatever you just said to.
So.
Because string compare just does absolute difference, right? It's not
yeah.
necessarily like whether it's the same or not.
string compared to compares to strings lexicographically.
Right. So you have two strings. You have a string that you're working with, right, like temp. You can say temp dot compare to and pass it the second string. And it's the same as string compare in C. So if it returns 0, they're equal. If it returns positive, then I think the first one comes after the second. And if it's negative, it's the other way around. And it's really doing it by just comparing ASCII values.
That's what I was thinking.
Yeah. But if you do this on words, right, it'll come out the way you expect. But if there's punctuation and stuff, it's based on the ASCII codes. All right, so questions about this? I understand if you don't ask questions, it doesn't mean that you say you understand it completely, but yeah.
Since we're going to be probably looking for multiple files, do you want the comment block in one of them or all of them?
Put your name and assignment number in every file. That's a general practice. And put something in the beginning of each file saying what that file is. Usually it's going to be one file per class. So you want documentation on the class as well as the methods and such. Yeah?
So would you make your new nodes using just a new method or a new?
Yeah, so one thing you're going to want is you're probably going to want a word list node and you're going to want a position list node as two other classes. Right? Because this node looks very different from this node. So you're probably going to have your three classes described in here, plus at least two other classes, one for these nodes, one for these nodes. All right, good for now. All right, let's take 5 minutes, and then I want to go through some code for some linked lists. And if we don't get to Eclipse, we started talking about Eclipse at the end of the last section, so you can catch that on the video. But we got plenty of time to go through Eclipse. But you can start developing this stuff from the command line with what you already know.
This is happening on Eclipse.
But this is going to, PA2 is going to be done in Eclipse, yeah. So I got to go through the rest of the assignment still. There's some more comments there. So we'll do that right after break.
Why is it a small one?
All right, so let's finish up talking about PA2. So there's some additional notes on here. We've already hit most of these. So you got to implement the classes yourself. Okay, don't use the built-in linked list classes. You're free to use Sentinel nodes, but you're not required to. Okay, we'll go through a linked list example after this. I'll probably won't use a Sentinel, but it's totally up to you. Okay. You probably want separate classes for the nodes of your two linked lists. We already said that. Keep in mind an object-oriented mindset when you're designing your code, which means, for example, when you define your position list, you don't need to be worrying about word lists and index utilities and all this other stuff. You can define a position list as just a class all by itself. It's a linked list of integers. And you can test it all by itself. You can just make an empty position list and just keep calling the add method, and it should just start tacking nodes onto the end. Right? And then you can go in, you can print those out or whatever. Same thing with the word list. You don't need to be reading from standard in. You don't need to be tokenizing. You just call the add method of a word list and just add words and positions and test it like that. So that goes along with keeping things modular. Make sure you understand every line of your code. Okay? This is the part of the course where typically people start getting creative with their programming. And I'll look at their code and I'll run it and it'll break on some bizarre statement that's miles away from anything we've ever talked about. And typically I'll ask, you know, what were you trying to do here? And they'll say, well, I didn't really understand that part. I found it online and it seemed like it made it work. Okay? That's not a situation you want to have, say, in the workplace, right? When you're writing code and you're being paid for it. and then your code breaks and you can't explain what it does. It was just something that seemed to work, right? That's not a good habit. So make sure you know what your code is doing, and think of it like this. If you were to go to somebody else in the class, could you explain to them exactly what your code does? Why did I put this statement here? What does it do? Okay, that's the sort of level of confidence you want in what you're writing. And if you're not sure how to do something, right, ask. And you can do that on a discussion, you can do it in class or whatever. But if you can't figure out how to deal with this try-catch business, right, it keeps complaining, don't just keep Googling and putting in different things until it compiles finally, okay? Because there's lots of ways to get it to compile successfully without doing the right thing. Okay, and ultimately on the tests, you need to understand the version of try-catch that we're talking about in class. So keep that in mind. You're submitting these classes, okay, but I'm going to run them with my own main program. So make sure you follow specifications exactly. Okay, your word list class has to be called word list with an uppercase W and an uppercase L. If you call it word list with a lowercase l, is that a big deal? Well, yeah, it is, because my program is going to be trying to construct a word list with an upper L, and if I try to use that with your constructor and it can't find it, I can't compile my program, I can't test your code. Okay, so imagine that you're doing this assignment on contract work for somebody, and here's, you know, what they want you to deliver, right? You've got to match their spec exactly. They might have 1,000 lines of code that construct a word list with an uppercase L, and none of that compiles because your word list doesn't have the same spelling. Okay, it really is a big deal. So try to make sure you're following the assignment specification exactly. And the last comment here, right, this can be a fun assignment. Okay, if you do this in pieces, like I say, it's a bunch of very, very small steps, but it's a lot of them. Okay. There's getting the mechanics lined up correctly, which you're getting practice in with PA1. But then the actual coding part of it, it's really small steps, right? If you already have a position list class defined, right? When you make a word list node, it's just, you know, string data, word list next, position list, locations. And that's how you define your node. And when you want to, you know, when you find this is the word that you're matching, and you've got this in a node called temp, it's just temp.locations.add parentheses your current value of the position. And that builds a new node and adjusts the pointers and tacks it on and all this kind of stuff. So try to go in small steps, and if you find that you're writing 15 lines of code every time you want to do something, take a step back, right, or come talk to me, and let's see if there's a way that you can be utilizing some of the machinery you've already put in your other classes to simplify that code. Okay, one way to look at this, you only want to invent the wheel once. You got a lot of different wheels, okay, but each one you're only going to code once, and then you're just going to use it. And ideally, you're going to use it to do something else and build up from there. All right, so submission, we're doing this project in Eclipse, and like I say, if we don't get to Eclipse today, you can start working on this just on the command line, and when you're ready to switch to Eclipse, you can just copy and paste your code in, right? But you can do this whole thing without Eclipse, but I want to get into Eclipse eventually. This is a good entry point. So in Eclipse, there is a way to export a project into a zip file, and we'll talk about that probably next week, exactly how to do that. And you got to do it exactly that way. If you just take your .java files and zip them and upload that, I'm not going to be able to use it. Okay, it's got to be a very particular version of an export from Eclipse, and I'll show you how I'm going to import that back into Eclipse. So we've done this before. I'll show you exactly what I'm going to do with your upload, which means that after you upload, you can try to reproduce that process. You can download the zip file from Canvas. You can import it into Eclipse into a new workspace, and then you can try to run it. And if it works for you, it should work for me. But if it doesn't work for you, it's definitely not going to work for me. Okay, so we'll go through the details of those. But ultimately, your upload to Canvas is going to be one of these exported zip files. And so this will be due 2 weeks from Friday. All right, so questions on all of that. So let's talk about linked lists. So let's build a simple linked list. So what should we call our list? What should we call our class?
Link.
Link, okay.
Should we make the number index
So
Zelda?
we'll do the California spelling. Okay, so what?
I was gonna say, do we make the number index Zelda?
Yeah, okay. All right, so we're going to define a class called link, okay? And our basic structure is going to look like this. And let's make a linked list of strings. I don't want to do integers because then I've given you position list. So we'll do a linked list of strings. So we have a string, and we'll just call this data. And we need a next field. And what type of object should next be? So if link is going to be our linked list, right, our linked list is comprised of nodes. So we really need another class here. So let's just call it node. And so this is actually a node. It has a piece of data which is a string, and it has a next field, and what is that next field? A what?
Another node?
It's another node, exactly.
No.
And we're not saying it's a pointer to a node, we're actually thinking of this as being the next node in the list. And it might seem a little weird because it looks like in this little rectangle we've got this big box with two rectangles, okay, but it's actually using pointers underneath. So we're not doing nested dolls, right? But from a programming perspective, we just think of a node as two pieces, a piece of data and another node. Yeah?
Can you have a class within another class that's only accessible by that class? Like, if we have a node for this linked list and we have another linked list with its own node, will it only pull from?
We wouldn't want two classes both named node.
Okay.
Right.
But you can't have a class within another class?
You can, but we probably won't. Just like you can define multiple classes in one .java file, but we'll generally avoid that. Okay, so our class node, we're going to have a string data, we're going to have a node next. And our constructor, well, let's construct it by passing it a string. We'll make our lives a little easier. So string data. So when we construct it, we'll pass a string, and it will set the data field equal to that string. And let's go ahead and set the next field equal to null. And that's probably all we need for our node class.
So in C, I know you have to use null all uppercase.
Yeah, it's all lowercase in Java. I don't know why. That's why I'm glad I don't teach this in 222 at the same time, because I'd get really tangled up. So yeah, from here on out, null's always lowercase.
Some languages it's nailed, isn't it?
Yeah. All right, so there's a node. Okay, two pieces of data and a constructor that conveniently lets us set the data field to the argument and sets the next field to null. All right, so what about our linked list? the linked list is going to be a collection of nodes, but we've got to have a handle to the first node. So this could be a sentinel node, but I'm going to do this without a sentinel. So can I use the word root without tripping people up?
Yeah.
We'll find out. So we're going to have a variable called root. It's a node, and we're going to set it to null initially because our list is empty initially. All right. We want an add method. So how do we add a piece of data to, let's just add to the end of our list?
We get a new node and we set the data field to the string that we pass.
Mm-hmm.
And we set that node next to null,
Mm-hmm.
basically.
Yeah.
I think so.
No, that's perfect. So let's create a new node. So node temp equals new node data. So let's insert in the beginning. So we'll insert at the start of the list. That makes our life a little easier. Okay, so we construct a new node. We're going to call it temp. And because we don't have a sentinel, there's two cases to worry about. Okay, so if the root is null, then we want to go from an empty list to a list containing just one node, which is this new node that we've just created. So we can just say root equals temp. Otherwise we have a situation like this. And this is null. So we have root, which is a node pointing to a node pointing to a node, and we have our new node, which is temp, and it's got some data field. So how do we insert this into the beginning of our linked list?
Yeah, temp points to root. Temp next is root, and then temp is root.
Okay, temp next. I almost drew an arrow. So temp next equals root, so I'm setting up this to point right here. And then root equals temp.
Right.
And now our linked list, which always starts with root, points to this new node followed by the other nodes that were already there.
I was wondering in the very beginning when you initialize root, why you don't have to write node root, new node, and then pass in.
You do. Well, no, you don't, because I want it to be null. You mean up here?
Yeah.
Yeah, I want it to be null, okay? And any object can be set equal to null. Now if I said node root equals new node, right, and then I set it equal to null, then that node that I constructed is orphaned, right? It's garbage and it'll get collected.
I was thinking rather you actually pass in null to new node. Like it would be node root equals new
But
node.
then I'm pointing to a node, I'm setting root to be a node that somehow contains null or represents null. And that's different from saying the root's actually null. We avoid this if we have a sentinel, right, which is part of why we did sentinels before. But without a sentinel, here's the picture. There's a list with one node. There's a list with two nodes. Here's a list with no nodes. Okay, it's fundamentally different. It doesn't have a node that's null somehow. It's the lack of any nodes at all that makes it empty. And that's really what's happening when we say root equals null. I don't know if that makes more sense.
That's it. That was,
okay.
yeah.
All right, well, let's code this. Okay, that should be enough for a node class. So two pieces of data, and the constructor sets the data equal to the argument and sets the next field to null. It creates an empty node. So, that compiles, we're done. All right, so that's our node. Let's make our linked list object. Okay, so that's the first node of the list if the list has any data in it, otherwise it's just null. So let's make a method to add a new piece of data to the start of the list. So we'll call that add. Public.
Because you're going to call that inside of your main function.
Yeah.
Or your main class.
Exactly. So make a new node to go in the start of the list.
Yeah, and stuff that's called in class doesn't return anything, right?
Say again?
If there's a function that is called only in your class, a private function, you don't have to return anything, right?
You're never required to return something from anything unless you need to use a return value.
Do you ever return stuff if it's just a private?
Yeah, you could definitely.
Okay.
Yeah, it's just a regular function. Private is just saying I'm only going to use it inside this class. But yeah, you might be returning something. You could make a private GCD method for your fraction class that returns the GCD and then use that inside a reduce method, for example. All right, so we make a new node with our data in it. We want to sandwich it into the beginning of the list. And there's two possible cases. So case one, the list is empty. In which case we just set the root equal to this first node, and that's the entire list.
Are there case statements in Java?
There are. It's called a switch statement, but this is just a comment. So our other case is where the list already has some data, and so we want to insert before the first node. So how do we do that? We said temp next equals root, and root equals temp. Yeah, except I got a return up here, so that'll kick us out. All right, that should be our whole add method. So that should sandwich a new node into the beginning, whether the list was empty or not. And that compiles, good. All right, one more thing to worry about, let's traverse. So let's print out our data in the order that it appears in the list. Well, the way we've always done this, have a temporary variable that starts off at the root, and if it's not null, print the data, and that's set temp to the next node. If that's not null, print the data, set temp to the next node, and keep going until temp is null. So we can do something like this.
Would this still be in your link class?
This is still in the link class. So I'll set temp to the root. And I'm switching to pseudocode here. So while temp's not null, print out its data and then set temp equal to the next node. Pretty simple print method, right? Point to the root, well it's not null, print out the data, move to the next node. And at this point, right, hopefully we're actually thinking of, hopefully we're not thinking of pointers anymore, right? We're thinking of temp as something that has a piece of data and it has the next node right after that. And temp.next really is, it's a node. And we're setting temp equal to that next node, and then we keep iterating.
So you can say temp.next and get two.
Yes, yep, absolutely.
That's why it's so hard to not think of pointer.
Yeah, yeah. Yeah, yeah. It should give you a snarky message if you use an arrow, but it doesn't. Yeah, so in this case, if we were putting in strings, we'd want to actually move down the list and compare the next piece of data to ours. And if it's bigger than our data, then we want to insert right before. So pair of pointers keep track of the previous and the next and all that stuff, right? So I'm conveniently skipping over that. And
That's
your
an add function, right?
This is for, so since we're doing strings, right, this is for the add method of the word list, right? And our nodes are more complex, right? Our nodes have a third field, which is a position list. But it's really just, you know, position list, space, positions or something. And initialize that to null maybe. And in our add method, once we have a temp.positions, that's the position list. And we can call methods in that by saying temp.positions.add, for example. All right, so did we compile this? That compiles fine. So how do we use this? So what's our main program look like?
I was just a question on mains. Are we gonna continue only turning in classes and not mains?
I don't know. No, certainly PA3 you'll do a main program.
Are you doing this because it's a lot of work and it's cutting down the work, or?
No, it saves me work actually.
Oh, okay.
Because I want to know that you're calling these things the right thing and that they get used the right way. And I can run your program and see that it's outputting the right thing, but I want to actually ensure that you're actually building these classes and they're doing the right thing. So I can have a variety of programs that use these classes in different ways to test them. So you could include a main, but I would be using my own stuff anyway.
Were you hand testing all the programs before, or were you doing programs?
No, I was doing them all by hand.
But now you can write a program to run through a bunch of different tests.
I could, but I usually don't. The reason being that any little deviation from what I'm expecting becomes a special case, and it ends up just taking a lot more time to deal with all the special cases. So I usually have a set of main programs, and I'll just copy and paste them into a main one at a time. And I'm testing it in Eclipse, so it's pretty fast. And then if something's going wrong, I've got the code right there, and I can pop in and see what's happening. So yeah, it's a fun weekend. But it's cool to watch this stuff working.
So for the position list, do we need to do any error checking at all for making sure that all of our numbers are in the right order? Because by default they would be. But
by default they would be. So if you add to the end of the position list, you should always be in good shape.
So we shouldn't have any problem with not checking that?
No, but this is something you put in your comments, right? When you describe what the add method does, make sure you say this adds to the end of the list.
Oh, okay.
Right? And then you don't have to worry about it, right? You've just absolved yourself of all responsibility. Yeah. All right. So what does our main program do? Well, let's do something like this. Let's make a link. What should we call our list? What's a good object name? Zelda. Perfect. All right. So we've got Zelda. That's a linked list. It's empty to begin with. So we can start adding things, right? So we can add a hat.
Now it's supposed to name differently.
And we can add a sword. And so on. And then at any point, we can say zelda.print. And it should show us all the stuff in our list. And it should show it to us in what order? Right here, what would be the first thing it would print? Two guesses, both wrong.
Sword.
Sword, there you go.
Inserting to the beginning.
Right, because we're adding to the beginning. So this is kind of like a FIFO, right? Or a LIFO, last in, first out. So if we add to the end, then it would be hat first. But the last thing we add is sword, so that's going to be the first thing that prints. If we do this right, I think. We'll see. Yeah, you said hat. I expected someone else to say sword. And then one. All right, so let's make a main. Let's make a main program. Zelda Dad, no, we don't want to do that. All right, what else should we add?
Shield.
Excellent.
Hook shot.
Hookshot. And those, what are they, Deta fruits or Deca fruits? Deca. Yeah, those things always mess with me.
Yeah, not that.
All right, and then let's just call the print method to print out the data. And that's the end of our list. Uh-oh, we didn't initialize it. Got to construct it. All right, should we run it? Ta-da, there we go. There's a linked list in Java. Yay. And this is long only because I got so many comments in here, right? The actual action in here is, you know, the add is construct, if, then do this, otherwise do this. Right. Does this make sense? You think you can take this and run with it and do other kinds of lists?
Everything, the whole thing.
Whole thing.
All of it.
You got 15 minutes. You can be done before you leave here. All right, questions. I'll upload this to Canvas under the link directory. Yeah. All right, there you go.
Is there a difference between input and input?
Input is for multiple files, but I don't know if it's necessary. All right, we got 5 minutes. Let me give you a 5-minute crash course on Eclipse. So if you've installed Eclipse and installed Java, you should be able to run it. I have to run it from the command line because I didn't install it right, I think. So ignore all of that stuff. There's nothing there. Nothing to see.
There's nothing burning there.
Nothing, no smoke. Let me show you what Eclipse will probably look like the first time you run it. Okay, and this is all I want to worry about is how do you get to a known state. So the first time you run it, it probably brings up something like this, welcome. It took me like an hour to figure out how to get out of here when I first tried this. So the main thing you want to do is go down to Window and Perspective and say Open Perspective, and you want to find Java. And it's different from Java browsing, so come down to Other, and there's a Java default. Okay, and the keyword is perspective, so Window Perspective, and you're finding the Java perspective. And it'll open up a set of windows.
You went to Window Perspective and then clicked on Java Perspective?
Yeah. Actually, let me show you what it will probably really do the first time you do this. 3 minutes.
Intuitively, starting a new project is not the first thing you choose to do.
No, but it will force Eclipse into the state that it's going to be in when you first run Eclipse. Which is this. So window, perspective, open perspective, and find Java default, and say open, and close out this thing. And this is your basic environment. Okay, basically you're going to have projects or packages over here, you're going to have code here, and here's where all of your input and output is going to appear. And these things, we can close these out or we can leave them. They don't do any harm, but we don't need them. And you're going to create Java projects. So file, new Java project, and give it a name. And then you're going to say file, new, and let's create a new class. And this is where you'll start writing your classes. So what should I call my class? I don't know. Call it my main class. And if you wanted to make a public static void main for you, you can click this box down here. And it says create that for me. You'll get a warning up here. Ignore that warning. It's okay. And say finish.
Is it like a cooler default package they want you to use?
Yeah, they want you to use your own package instead of the default. We'll talk about packages. So here's my main class, and it's already written most of it for me. So I can come up here and I can add my own stuff. Alright, and we'll talk about this stuff that's popping up later. It's trying to help me, but I just added a print method on here, and then you can go to run and say run. It'll ask if you want to save this, and you can say yes, and you can say always save it. And it runs, and your output appears down here. Yay. Alright, so that's the really, really brief introduction to Eclipse. But the main thing you need to worry about is opening this perspective and look for the Java perspective. Otherwise, you got weird windows and there's nowhere to write your code.
Oh yeah, because that's what you were outline. Right?
Yeah.
We already got to play with it last. We were playing with Eclipse last term.
Yeah.
We switched over into the studio.
Okay. Eclipse is a little more straightforward to me, at least, but
yeah, a lot because you don't have what is it? It's like grapple.
Gradle.
Yeah, Gradle. They're the package that you have to use for the.
I still don't know what a Gradle is, but I use them.
I think it's used to interface with some of the Android hardware.
Yeah.